sharing. Okay. Let's see.
I got my Apple probability app set up because whenever I
Sweet.
don't, it bumps me on my test.
Oh, really? That's weird.
I lost my applet. I had to bring it up and it bumped me out of the test. Okay, I'm up.
That's weird that it does that. Okay. Are you ready for number 3?
I see a study. I don't see any of the other questions there.
The number 1 and 2?
You know what? I'm on my homework quiz. Hold on.
Oh, shoot.
Whoops. I clicked on the wrong thing. Okay, I completed my homework. I don't know if I understood everything, but I went over it again. And I actively participated here.
Okay. Number 3. The symbol for the true population proportion is which of the following?
It would be P because that's true. That's the true symbol for it.
Which one?
P because it's the most accurate. I know they say accurate, but it's the most true.
Sorry, say that again.
C.
C. What P hat is what is P hat then?
I have to go look that up here. P hat is.
Oh, wouldn't P hat be the?
No, because there is a.
Oh no. Yeah, no. Yeah, I see what you said. P hat is X over N, where X is the number of individuals with a certain characteristic. Okay. Where did my pen go? For the next 2 questions, suppose N is 100, P is 0.25, and P hat is 0.10. The requirements for constructing the confidence interval are satisfied. So you do.
That's true.
5, yes. Yes, they are.
Number 5, the requirements for conducting a hypothesis test are satisfied. True.
Aren't they the same? Or
You still have to have the same similar information.
yeah. Because aren't they both like, if you can do, is if p times n is greater than 10, and then p times 1 minus, or n times 1 minus p is greater than 10?
You got your formulas memorized.
A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find the point estimate of the proportion of first-degree murder defendants who are found guilty in the state, divided by 60. Is 0.75.
Give me the formula for that, please.
So p hat equals x over n. So x is your number of interest, so 45. And then n is your total population, so 60. Not your point of interest, sorry. It's like the number that, I guess I don't know what it's called, but does that make sense?
It does, because I remember reading that, but I want to do it here right fast.
Okay.
I have 7.5. Oh, I didn't put the 6 in.
You had 0.75?
Oh, there it is. I didn't put my 0 in. I got to be more careful. Yes, I did.
Did you ever get your calculator figured out?
Yeah, I got it moved over to the next decimal.
Sweet.
But I didn't figure it out. I had someone else help me.
That's
question
tough.
7. Determine the margin of error for this 95% confidence interval. So that formula is m equals
Margin of error.
look it up here.
Oh, Brian's calling.
Maybe he's going to attend it with us.
Hey. Oh, no, you're fine.
Done outside.
Sorry.
You need some help?
No, I got it.
All right, let's get thrown in there. Thank you, Adam.
Yeah, so right now we're in the quiz, but let me ask Wanda. Wanda, here, let me put you on speaker. Brian, I've got Brian on the phone right now.
Uh-huh.
And he's wanting to know what we're thinking about doing for the group project. Yeah, sorry, group project.
I think who wants to, I don't know how to conduct it, but I think Oreo eat them after we're done.
Yeah, I like the Oreo idea. When I was reading it, I was like, oh, this fits perfectly. So.
Okay. I'm pretty sure I have a scale that would work.
Okay.
For it. So if you guys want, I'd be happy to like collect the data or whatever. So.
Okay, yeah. Let me open it up really quick. And then, because I think there's like, one person has to do each, or like put all the information together for each part of this project, right? Is that? So I can do the design the study. Let me find it. So I was wondering if we could just Let's see. So do we each work on every step of it together, or does one person take a step?
That's kind of what I thought it was, but I could be wrong. I don't have it in front of me.
So, okay, so it says the main writer will be the one to collect everyone's ideas and suggestions. They are then responsible to send out the document for feedback and apply the feedback to the document before submitting it. The writer can assign out different parts of the writing as well. For example, if you're in charge of describe the data, you could ask one of your group members to create and label the charts and send them to you to be grafted into one main document. So, study. So we could just, we each take one and then we work on it and then we submit it to everybody to review and then we can kind of finalize it.
Yeah, and then we like kind of pull it all together, right?
Right. So, let's see. Yeah, I can do the design the study this week. And then I'll email you guys everything, like I'll fill it out and then I'll email you guys the thing and then you guys can critique it.
Okay,
Does that work?
deal. Sounds good.
Okay.
All right, sorry guys.
No problem.
Totally unexpected. My mom just called me earlier and told me. So, anyways, thanks for you guys being an awesome group. You guys are fantastic, and I wish I could be there to help with the quiz, but sorry.
Yeah, no worries. Take your time.
All right, we'll talk to you later.
Talk to you. Bye. Okay. Okay, are you ready for the quiz now?
What we just discussed, are we going to get together this Saturday to rediscuss it or just make assignments today?
So I think we're gonna just make assignments and then I'll send out the assignments and
Okay.
then so like I was gonna do I can do it this week, the design the study. And so what we'll do for it is we'll just assign like a step to everybody and then that person will do it. And then once they're done with it, they'll email it out to everybody for people to kind of put their input in on it and kind of critique it to be what like everybody wants it to be, you know?
Okay.
And then we can submit that one part. So this week I will do it and then I'll send it out and then we'll critique it. And then like next week, either you, Brian, or Myra can do that one, send it out, we'll all critique it type thing.
Thank you.
Yeah, does that sound okay?
Yeah.
Okay.
Because this is new territory for me, so.
Kind of tough. We're all so far apart. Okay, so back to the quiz. Determine the margin of error for the 95%. Okay, I remember this. Do you need the equation for this question?
Yeah.
I think I lost you.
I'm here. I'm still here.
Oh. I was saying, do you need the equation for this question?
Yes, I do, please.
Of error is, so it's z times, let me make sure I have it right, z times, so then all of this is going to be under the square root except for the z, p hat times 1 minus p hat all over n.
Is that a square root?
Yeah, so that's all under the square root. And then you find our p hat in the previous problem.
Our p hat was 0.10.
It was 0.75.
Whoops, I'm looking at the wrong question.
Number 6. Is that what you got for number 6?
Number 6 I thought was 0.75.
Yeah, yeah. So you're using number 7 for your p hat. So number 6 gives you your p hat for number 7.
Okay.
So your p hat is 0.75.
Seven. Create a 95% confidence interval for the true, is that, yeah, that's when we're on. True proportion of the first degree murder trials in this state. There the verdict is guilty, and put your answers for the margin of error, lower bound and upper bound. Isn't there a way to use one of the
You there?
yes,
Sorry.
putting it in a one proportion or a z test?
No, that's not yet. So we're doing the confidence interval part of that, and that's before, in the lesson, that's before the z-test. So the equation that you use is, so z, remember z is like, you've got that chart, z for 95% confidence interval would be 1.96.
Yep.
Okay, so you do the 1.96 times, and then this is all under the square root, p hat, which is 0.75, times 1 minus 0.75 over n, which is 60. So this is what you're, here, let me write it out, and then I think you can understand it better when you see it.
Oh, Father God, help us.
So this is what it looks like.
Let's see. Because it's a plus minus. And the plus is, yeah, 1.96.
So this top one right here, this is the margin of error equation. And then this is it with it filled in. So this is z times this equation.
Can you hold it up just a little bit more? Whoops.
Here, let me darken my decimals. I don't think I can see them.
Okay. So when we compute that there, $1.96 0.75 parentheses was that 1.075?
It was 1 minus 0.75. Like
1 minus 0.75. 60. So I got 0.10957.
I got 0.110.
Yeah,
Let
I
me
got
do
to
it
round it
again to
up.
make sure.
Yeah, when you round it up, it equals that.
Let me do it on the app that Brian was talking about.
So you're going to put in 1.196, 1.96. And which way are you going to shade it? Because it says to the lower first. Six. 7. Six, 6, 4. Margin of error. Yeah, I went last night to feed my dog and found her dead.
Oh no.
So I've been kind of like,
Oh, I'm so sorry. That would be so hard. How old was she?
she was old. She was 20, but she was in good shape.
Oh, I'm sorry. That would be hard.
It is hard.
Yeah. I can't imagine.
So are we on number 7 still, or moving on, or
Did you get number 7?
0.110?
Yep. So number 8.
Is there
So then you take so number 8 you take our P, where did that go? P hat minus that 0.110, which our P hat is 0.75. So it'd be 0.75 minus 0.110. Ouch, which is, sorry, 0.64.
I can't. 0.75 minus 0.110. That's 0.75 minus 0.110. I'm getting 0.64.
That's what I'm getting as well. I'm going to put it into that Excel that they were showing us and double check everything.
The Excel that they're talking about is the QIP.
No, I think it's a new one.
QDS.
Yeah. No, CDA. It's a new one. Let me make sure though. I'm opening it right now.
There it is, CDA.
Where did it go? Oh, here it is. Yes, it is CDA. So then you can just put everything in here.
Is that the one sample z-test per proportion?
Yes. Oh, we should have just done this from the beginning. Okay. Makes it a lot easier. Let's see. So in that
So we
part,
put it in. What is X then? N was 100.
so X would be, sorry. When I click on one thing, the other thing goes away. Okay. So our X is 45 and our N is 100. Or sorry, 60. 95% confidence interval. Yep, so we're...
And is it greater than or lesser than?
It is...
Because it's lesser than, because we're doing the lower bounds.
It doesn't say really. Right? Oh, no. So the lower bound, that doesn't have anything to do with like the greater than or less than. That's just trying to say like when you're 95% confident that the mean is between these two numbers are your confidence interval. The lower bound is the lower number and then the upper bound is the upper number. Does that make sense?
It does. I wish it would stick. So I get the confidence interval, the lower one is 0.640.
So we got it right. And then I think I'm going to add a 0 to all my answers. Yeah. So number 9. So then we get 0.860. Yep. I don't know why I wasn't doing this the whole time. This makes it easy. So if you increase the sample size from 60 to 80, what do you expect to happen with the width of the confidence interval? It would decrease.
Decrease.
Yes. To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/2. What is the smallest N can be and both requirements still be met? It would be 20, right?
Because how do we do that?
So this is the equation where it meets, so it's P times N has to equal to, or it has to be greater than or equal to 10. So I just know that like half of, or 2 times 10 is 20, because you'd have to, you're halving 10, or you're halving something to get 10. And then for the other requirement is, let me make sure I'm right. I think it's N is, I wrote it down, but who knows? Oh, N times 1 minus P has to be greater than or equal to 10. That's from last lesson. So I think it would be 20.
It sounds correct.
Does that make sense? I don't.
Or N
Let me
times.
show you. Let me show it to you. I have a hard time like reading.
N times 0.5 is greater or equal than 10 times N over 0.5.
So where's my camera? These are the
There are two separate tests. Yeah, 2 separate tests.
Yeah. So
or
then
N times 0.5 like N times 1 minus P. So both answers are 20.
Yeah. So for the next one, it's the same.
To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose that P equals 1/10. what is the smallest n can be and both requirements still be met? So it's the same equation that we used previously in the in question 11. N times p is more or equal to 10, or to equal to 110. Is that correct? And
Wait, yes.
n equals brackets 1 minus p, which is 110. It'd probably
Yeah.
be easier to put it in a decimal form, huh?
Yeah, so 0.01. Oh, shoot, no, it's 0.1. That's where I was getting confused.
The other equation, which with the more or less than equal to,
So I got a 100 for that.
because they both should equal the same number.
No, they're not always going to equal the same number. They just both have to be greater than or equal to 10, both numbers that you get.
Go over the second formula, please. My mind's a little bit boggled.
No, you're good. Let me write it and then I'll show it to you. Here, let me start kind of from the beginning. So you have to, let's see.
I got the one.
But... You got the first one? Okay, so here are the two equations. So P is the 0.1 that they give us, times we're trying to find N greater than or equal to 10. Then I know that, just kind of off the top of my head, that 1/10 of 100 is 10. So I know that this is going to be 100. So because 0.1 times what will get you greater than or equal to 10. But we're looking for like the lowest amount. So something equal to 10. So I knew that was 100. So then I just plugged it in here and made sure that it's greater than or equal to 10.
So N,
so then I did.
But we don't know what N is.
No, that's what we're trying to find.
1 minus 0.1 equals 0.9. It's not greater than 10. Am I doing things wrong?
Say it again. It kind of broke up.
What?
Are you doing the second one?
For the the second one, 1 minus P is greater or equal to 10. If you put 1 minus 0.1, it equals 9. 0.9.
And then you multiply it times the N, which I'm guessing would be 100. I'm guessing it from this equation.
Okay.
So these don't have to equal each other. But they both have to be true in that they're greater than or equal to 10.
Okay.
Does that make sense?
Oh, yeah, it makes sense.
Okay. So then I put 100. So number 13.
12.
Are you ready for 13, or do you want me to explain it more?
Nope. For the
Okay.
water quality study and the reading, about 60% of the microinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using a significance level of 0.05 with the following hypothesis. The Ho is equal to 0.6, the Ha is less than 0.6. They collect new data, and this time N equals 80 and X equals 38, indicating good health. The conditions for conducting a hypothesis test are satisfied, true or false. Well, it says that our mean is more than our standard deviation.
So this question's asking the same thing that we've been doing in is using those two equations that we've been. So the P times N is greater than or equal to 10, and then the other one.
Mm-hmm. So we
But
have
I
to
don't know
continue.
what would our P be? Our P is X over N, right? Yeah, so it would be, so to get P, do 38 divided by 80. Oh, look. So if you open that, the CDA Excel,
Yeah.
and then you put your X and N in, and then you make sure your confidence interval, doesn't matter, I guess. Doesn't say it. So,
Our X is 38.
and then in the right,
Whoa,
does
what
it give us,
happened to my thing here?
did it close your quiz?
No. It like my file zapped. That was weird.
Oh,
I'll have to open up it again.
okay.
That was strange. One sample z-test for a proportion, correct?
Yes.
Because you got to make sure you got the right file. X is 38. N is 80. Does it say what our null is?
Yeah, it's the 60% or 0.6. So the null hypothesis is H of O in that equation that they give you.
And is it, what is type of test? Greater, less, or equal?
It's less than, because the hypothesis is P is less than 0.6.
So it's saying that our null hypothesis is 0.6.
0.6. Yep.
So it's greater than the standard deviation. So it's true.
So the way that you know it's true is in that one sample z-test. If you look at confidence interval requirements, oh wait,
38.
sorry, hypothesis test requirements. Sorry, I said wrong. The hypothesis test right above it. You just make sure both are greater than 10. Both little sections, and then you can say true. Does that make sense?
Both are more than that. That's one of those rules.
Yep. Okay, number 14, p-hat. So it gives it to you in that little z-test, the 0.475. And then our test statistic is negative 2.282. Do you agree?
What is the p-hat?
So, so the p-hat, if you look on that one sample z-test, there's a section that says p-hat, and then it gives you the answer.
What I have is I have a p-value, but I don't see, there's the p-hat. Thank you.
Yeah, right above it. Uh-huh.
I'm just trying to
I love
read
this
these.
Excel. This makes it easy.
So then the
And then the test.
test statistic is negative 2.282.
Yep.
It's like learning a new language. It's like, do I say it right that way? You know, you get
I know. I'm like, I hope I'm like teaching you right, and that when I like I'm giving answers or like explaining something, I'm like, I'm nervous that I'm going to submit it and it's all going to be wrong. Like, oh, I think I understand it, and then I don't.
And then it says, what is the p-value for the test? And the p-value is 0.011.
Is what?
The p-value is 0.011.
That's what I got too. So the decision is, so our level of significance is 0.05, and our p-value is 0.01, so it's less than, so then we reject it.
Reject the null.
Sweet.
But it doesn't say in these answers, reject the null. It says there is insufficient evidence, there's sufficient, there's insufficient, there's sufficient. There's only one that says
so
there's,
when I'm on number 17.
there it is. Reject the null, because it's less than the standard deviation.
Yes. And so when we reject the null, we have sufficient evidence, right? And then when we fail to reject, we have insufficient evidence. Is that right? Or am I having backwards?
I'm always confused about those things.
I think during the thing I wrote it down because it finally like clicked in my head.
It has to be on one of those pieces of papers we take for a test.
Yeah. Okay, so when we reject the hypothesis, we always have sufficient evidence, and when we fail to reject, we have insufficient evidence.
Say that again.
So this one we would have sufficient evidence to conclude the water quality in the area has decreased. Because that's what our alternative hypothesis was. Wait, no, that's what our, oh, I don't know. I confuse myself so much with this. So we're rejecting the null, so that means the alternative is true. So yeah, it's there's sufficient evidence to conclude the water quality in the area has decreased.
There is sufficient evidence to conclude the water quality in the area has not decreased.
It
So it
has
is.
decreased.
It has decreased. I wish I could understand the terminology on this because it confuses me.
So the way that I've kind of, like, in my mind, so like the p-value is less than the level of significance. You always reject it. And when you reject the null hypothesis, you have sufficient evidence. But when you fail to reject it, you have insufficient evidence, always. And then, so you either say you have sufficient or insufficient based on that, and then you state, if you reject it, then you state the alternative hypothesis.
When the p is less than the significance, you reject. When you reject the null, you have sufficient, and when you fail to reject, you always have insufficient, always.
Yes. That is like, I find this last video that I watched finally, like, I don't know, it clicked. I did terrible on the test because I couldn't understand it.
I just can't get that stuff to stick in my brain. I always have to review for each thing, each answer, with each question.
Yeah, it's just so wordy and like, I don't know.
Okay.
So I submitted it and got a 100.
See what hopefully I made my decimals in the right place. Woohoo! Me too.
Yay!
Thank you
My
for
grade
your
beats that.
helping me through this.
No problem. Do you have any
Good job.
questions? Or?
Just on that one, on question 12, I'm still really confused on it.
Let's see. Oh crap. I closed it. What was the question?
To conduct a hypothesis test for one proportion, two requirements must be met. Suppose that p equals the 1/10, which is what is the smallest n can be, and both requirements still be met.
Okay, so what was the proportion? 1/10?
Yeah.
Okay, so for that one,
You wrote it down on the
So-
paper.
yeah, you have those two equations, right?
That is the p times x is more or less than 10, and the n 1 minus p,
Is greater than or equal to 10 as well.
10.
So then what they're asking, let me think of a way to word this. So what they're asking is for the proportion, they're giving you so for P, they're giving you 0.10. And then they're asking times, so we're going to just look at like that first P times N is greater than or equal to 10.
Thank you.
So then what they're asking for this question is if I give you this proportion, and what number can you multiply it by to get a number that's greater than or equal to 10?
Okay.
So, but they want the lowest number you can multiply it by. They don't want like 1,000, like some random big number. They want what low number can you multiply it by to get as close to greater than or equal to 10. So if you take the P, which is 0.10, and then what can you multiply 0.10 by to, or yeah, 0.1 by to get 10?
Well, we
It
said
would
it
be
100.
100, yeah. So basically, if you look at it tithing terms. 10% of what number is 10? 100.
100. Thank you. That's it.
Yeah, so that's what it's asking. So then when I got that number, I was like, okay, now I just need to plug it into that second equation and make sure that that number is greater than or equal to 10.
So you just plug it in there, and of course it was.
Uh-huh, and then make sure that the number you get is greater than or equal to 10.
Thank you for using the tithing thing. That makes a little bit more
Does that help?
applicableness.
These are a good number.
Thank you, McKenna.
No problem.
And I hope and pray that Brian's heart's comforted, and I hope Myra can keep on board with this, with having to work so many hours. I hope and pray she can keep up with our studies.
Yeah, I feel bad. But
So I'll look for you. Are you going to email me through the BYU email?
which one do you like better?
Probably the BYU, because then I can keep my personal separate from my school.
Okay,
Do you
yeah,
have
what's
my
your
BYU?
I don't.
It is CUR17010@byu.edu.
So CUR17010@byui.edu.
Yeah.
Okay, yeah, I'll email that one then.
Thank you.
You're welcome. Have a good night. I'm sorry about your dog. That's so sad.
Yeah, I had my son bury her because I drug her out from where she was and put her where we needed to bury her.
Mm.
And I'm
Oh,
sad.
That's hard, yeah. I'm sorry.
Yes, I love